Hello students, welcome to 60 out of 60 in KCET Chemistry 2025 series in just 200 days. So students, today we are going to complete this chapter, that is alcohols, phenols and ethers. So today we are going to discuss commercial alcohols and everything about ethers, their methods of preparation, their chemical reactions, everything we are going to do, and then we are going to practice a lot of previous year questions. Okay, so one more request, please join our WhatsApp channel. The link of the WhatsApp channel will be there in the description section of this video. So please go there, join the WhatsApp channel so that you can access the notes, question papers, everything very easily from our WhatsApp channel. Okay, so now I want everyone to sit with a notebook and a pen in my class and note down all the reactions that we are going to discuss and also practice questions with me. Okay, so yes, I hope all of you are ready. Let's get started without any delay. Okay, so first of all, as every class we discuss how we have covered this chapter. So this is actually important so that when you revise you should know that how many parts are there. So there are 4 parts in this chapter. First part we have already covered: classification, nomenclature and the structure. In part 2, we have discussed preparation of alcohols, preparation of phenols and the physical properties, right? In part 3, we discussed chemical reactions of alcohols and chemical reactions of phenols. Next, very important, part 4, here we have discussed commercial alcohols, and today we are going to discuss commercial alcohols and everything about ethers. Okay. So now let's get started. Weightage, as I told you many times, this chapter you can easily expect 3 to 4 questions. Okay, and organic questions, each chapter is related to one another, so you cannot afford to leave any of these 4 organic chapters. So please prepare all the 4 organic chapters. Okay, fine. Next, coming to today's lecture, that is commercial alcohols and ethers. So in commercial alcohols we are going to discuss methanol and ethanol, a very brief discussion about them. Then in ethers we are going to discuss their methods of preparation. Okay, then the physical properties and the chemical properties or chemical reactions. Okay, so now coming to the first part, that is commercial alcohols. First one is methanol. Now here you should know that methanol is also called as wood spirit. Okay, why it is called as so? Because it is prepared by the destructive distillation of wood. Okay, now there is some other methods also for the preparation of methanol. So the first one you can see, just you take carbon monoxide, that is CO, okay, with H2 in presence of catalysts like zinc oxide and chromium oxide, Cr2O3. This will give you CH3OH, that is your methanol. Okay, now what are its physical properties? So methanol is a colorless liquid. Okay, it is poisonous in nature and it is used as solvent in paints, varnishes and chiefly for making formaldehyde. Okay, so questions are not much asked from this part, but you just have to know, have certain idea, like it is known as wood spirit. This is one important point that you need to keep in your mind. Okay, next coming to the second one, that is ethanol. So how ethanol is prepared? So first, from the molasses, okay, sugarcane which contains sucrose, okay, that is first broken down to glucose and fructose. Now this glucose and fructose by an enzyme zymase gets converted to, zymase enzyme converts this glucose to ethanol and carbon dioxide. Okay, so first of all, this is your, you can say sucrose. Okay, sucrose is converted to glucose and fructose in presence of the enzyme invertase. Okay, next glucose or fructose is converted to ethanol and carbon dioxide in the presence of an enzyme zymase. Okay, so you must remember these two enzyme names. Okay, next properties, if you see, these are very much similar to your methanol: colorless liquid, poisonous, it is used in making paints, varnishes. Okay, fine. So now we'll go to the next topic, very important one, ethers. Okay, and in ethers, first we will talk about preparation of ethers. So now see, ethers can be prepared in 2 methods. One is your dehydration of alcohols. The first method of preparation of ethers is dehydration of alcohols, and the second one is Williamson ether synthesis. Okay, so this is a name reaction, so important one, name reaction. Okay, so first one is dehydration of alcohol, second one is Williamson ether synthesis. Now we will see both of these methods of preparation. Okay, so first if we talk about dehydration of alcohols, now what is the mechanism here? Just you see here, first of all you take, I'll just tell you what is the trick first. Okay, so we have ROH, 2 alcohols you need to take, okay, at a temperature of 413 Kelvin. Okay, heat it at temperature of 413 Kelvin. What happens here? This water is removed. Okay, H and OH is removed. So what will I get here? We will get ROR dash. This is your ether. Okay. Now if we see the mechanism for this one, what is the mechanism? See, first of all, ROH is there. In presence of any acidic medium, this gets converted to RO plus H2. Okay. Now there is another R dash OH reacts with this one, RO plus H2. Okay. This lone pair attacks on this one. This goes out and we get R dash OR. Okay. Here there is one more H plus. Now this one is given back to give you R dash O and R. Clear? So what you have to remember, that at a temperature, lower temperature at 413 Kelvin, if you treat alcohols, they gets converted to ether. Okay, but if you do the same reaction at 443 Kelvin, there is dehydration reaction and we get alkenes as a product. Okay, next coming to the second method, this is more important, that is Williamson ether synthesis. So let me make a line here. Okay, now see, in Williamson ether synthesis you need to have one RX and we have one R dash ONA. Okay, here this part ON minus Na plus. Okay, now what happens here? This is a simple nucleophilic attack. Okay, so if you see that this one delta X minus and this is delta plus, right? X is electronegative, just it has to be slightly negative in charge because X is more electronegative than R. Then this is delta positive. Now here what happens? This RO minus attacks on this R plus and this X goes out. So what I will get here? We will get R dash OR, R dash OR, and then we have NaX. Okay, and we have NaX. Now here are some criteria, the conditions that you must remember. First is this Rx must be primary. Okay, Rx should be taken as primary. Now this one can be anything. Okay, this R dash can be anything, but this R must be primary. Okay, very very important condition. Now see, for example, suppose you want to prepare one ether like this. Suppose it is like this, CMe Me OCH3. Okay, for this you need to tell me which is the correct Rx and correct RONA. Okay, so there are two possibilities here. See, you can have like this, that Me3, okay, CX plus, let me use different color, plus CH3O minus Na plus. If you take this one, okay, then this reaction, this combination will not give you this product. Okay, because what is the condition? Your Rx should be a primary one. So what should be the correct combination taken here? The correct combination should be CH3X plus Me3, one second, plus we have Me3CO minus Na plus. If this is there, okay, yeah, so now what will happen? This one will attack on this one and this one will go out and we will get the corresponding ether. Okay, but if you take this combination, it is wrong. Okay, so what you have to remember, that the Rx part should always be a primary halides. Okay, so what is basically this reaction taking place? This reaction is taking between alkoxide, this is called as alkoxide, and a haloalkane. Right, so alkoxide and haloalkane should react to give you a ether and a sodium halide, right? But the thing that you must remember is, this is very, very important. Okay, so let us make a note here. Note is Rx must be primary. Okay, please note down and put a box in this. This is very, very, very important point. Okay, fine. So now these are the two methods of preparation. I hope it is clear. First one is simple, dehydration of alcohols at a temperature of 413 Kelvin. Another is Williamson ether synthesis, where we are taking Rx and R-ONA, alkoxide and haloalkane. Here the thing that you must remember is the haloalkane must be primary. Okay, fine. Next we can go to the physical properties of ethers. So ethers, as you know, the structure is like this. Okay, so this is delta positive, this is delta negative, this is delta positive. So there is a polar nature of the bond, right? So the CO bonds in the ethers are polar, and thus ethers have a net dipole moment. So there is a net dipole moment, because here you can see it will be in this direction, this will be in this direction. So there will be a net dipole moment. So ethers are polar molecules. Okay, first thing. Second, talking about their solubility. So ethers are soluble in water because of the oxygen of the ether can also form hydrogen bond with the water molecule. Okay, so it exists like this. Suppose this is the ether. Okay, and we have water. Okay, so there is a hydrogen bond between the oxygen of ether and hydrogen of water. Okay, due to this hydrogen bond, what happens? Ethers are soluble in water. Okay, so these are two basic properties. Now we'll come to the most important thing, that is the chemical reactions. Okay, so in the chemical reactions of ethers, we have two main categories of reaction. First is cleavage of CO bond, and another one is electrophilic substitution reaction. Okay, first one is cleavage of CO bond, and the next one is electrophilic substitution reaction. Under electrophilic substitution reactions, we have three reactions. First is halogenation, then we have nitration, and then we have Friedel-Crafts reaction. Okay, so now coming to the first part, that is cleavage of CO bond. This is very, very, very important. I cannot say how much important is this one. 10.3.1, right? Yeah. So now you see what basically happens. This is one ether, right? R1OR2 is written as an ether. Okay. Now when you treat it with HX, what will happen? First, the lone pair of oxygen will attack on this H plus, right? So we will get this compound. Okay, now this X minus is there. Okay, now this X minus can either attack, okay, one second. Okay, this X minus can either attack on this one and the bond can break like this, or the X minus can attack on this one and the bond can break like this. There are two possibilities. Okay, so whether the X minus will attack on R1 or will attack on R2, that depends on two conditions. Okay, that we will discuss. Okay, so first step is very clear. O takes this H plus and we get a compound like this. Now X minus can attack either on R1 or can it attack on R2. Now whether it will attack on R1 or it will attack on R2, that depends on the two conditions that we are going to discuss. The condition number 1. So this is conditions, okay, that you must remember. First condition is, see, if R1 and R2 both are primary or secondary, okay, R1 and R2 either they are primary or secondary, they are normal primary and secondary. Okay, they are simple primary R1 or primary secondary R2. Okay, then the reaction takes place by SN2 mechanism. Okay, now that means what? If it is taking place by SN2 mechanism, then where will X attack? X will be attacking on less hindered site. Okay, if both R1 and R2 are either primary or secondary, normal primary and secondary, there is no resonance stabilized, nothing, okay, then the reaction follows SN2 mechanism, and if SN2 mechanism is followed, then X minus will attack on the less hindered site, okay, X minus will attack on the less hindered site. We will do examples, it will be clear, okay. Next, if any one is tertiary out of this R1 and R2, if any one is tertiary or resonance stabilized primary or secondary is there, resonance stabilized primary or secondary is there, then the reaction follows SN1 mechanism, okay. SN1 mechanism follows means what? There is a formation of carbocation, okay, and X minus will attack on this carbocation. Clear? Once again let me repeat, this is very important students, please mark it as very important. Whatever questions you expect from ethers will be from these topic, this particular topic, okay. Once I'll give example, it will be more clear, but let us understand here what I'm saying. In a ether there are two sides, right, R1 and R2. You just need to check these two, R1 and R2. If both are primary or both are secondary, if one primary, one secondary, anything like this is there, then the reaction proceeds, this X minus attacks proceeds through SN2 mechanism, and in SN2 mechanism X minus will attack on the less hindered site, wherever there is smaller group is present, X will attack on that side, right, and another side will give you alcohol. Clear? Now if that one of the R1 and R2 is either tertiary or it is resonance stabilized, if it is resonance stabilized or it is tertiary, then that part will form the carbocation part, okay, and the reaction follows here SN1 mechanism, and it will form a carbocation, and the X minus will attack on the carbocation, okay. I think it will be very confusing for you people, but do not worry, we'll do with example, it will be very clear, okay. So now let us see this example, okay. First method, what happens, see, first O, this lone pair of O will attack on this one, so I'll get CH3, okay, O plus H, then we have CME3, right. Now if you see, this side is a tertiary one, right, so I told you if tertiary is there, then carbocation formation will take place, right. So how will this bond break? This bond will break in such a way that there is a formation of carbocation, right, this bond will break in like this, so I will get here, we will get CH3OH, this is one formed, plus CME3 plus charges here, right. Now this X minus, what is this X minus here? I group, so I group will attack on this carbocation, so what will I get? We will get I minus is attacked here, right, this is the product we will get. So this is one example where one side we have primary, another side we have tertiary, okay. Next you can see this one, phenol group is there, O group is there, CH3 group is there. So whenever phenol is attached, okay, like one benzene ring is attached, then you need not think anything, you must break the bond here after O every time, okay, and H will come here and CH3I will form. So remember, if there is a pH group, phenol formation is mandatory, okay. So there will be a formation of phenol here, so we will have phenol plus CH3I. Now why this is happening? Because you know this bond cannot break, right, this is very difficult to break this bond. Phenol, as you know, this is like, suppose O is there, this structure is like this, right. So this oxygen is having in resonance here, right, so that is why we cannot break this bond, this bond breaking is difficult here, right. So that is why what will happen, bond will break here only and O minus will form, okay, and CH3 plus will form, this is H plus, this is I minus, so CH3I will form and phenol will form here. Clear? Next one, if you see, okay, next example let us see. So now if you see this carbon, right, this carbon is attached to two more carbons, so this is a secondary carbon and this is a primary carbon. As I told you, if there is both side either primary or secondary and there is no resonance stabilized, the reaction proceeds by SN2 mechanism, right. In SN2 mechanism, what will happen? Nucleophile will attack on the less hindered side. So if you see, this is more hindered, this side is more hindered, right, and this side is less hindered. So the nucleophile, that is I minus, will attack on this one, okay, and this one will form like this. So what will be the product I will be getting? We will have cyclohexanol plus CH3I. Getting? So I hope all these three examples are very clear, okay. Next we will go to the second type of reaction, that is 10.3.2, okay. Electrophilic substitution reactions. So first of all, here you have to understand this OCH3, okay, this is an electron donating group, okay. If electron donating groups are ortho-para directing, where are these directing? These are ortho-para directing groups, means the product, the electrophiles will be attached at the ortho and para position. So if you take Br2, what I will get? We will get OH, Br at the ortho position plus OH, okay, and Br at the para position. Now remember, para will be the major product here, okay, para will be the major product. Now similarly RCOCl, this is Friedel-Crafts acylation. So in Friedel-Crafts acylation we will get OH here, then we will get COR ortho product, and then we will have OH here and we will get COR, okay. So we got one ortho and para product. Next, if you see RCl, right, this is Friedel-Crafts acylation, okay. So sorry, Friedel-Crafts alkylation. So I will write the name of the reactions also. So this is your halogenation reaction. This is Friedel-Crafts acylation, right. So this is first reaction, this is second. Next we have Friedel-Crafts alkylation. So for that also you will have one second, okay, one small mistake I did here. This one is your OCH3, right, I wrote OH, sorry for that. These are all OCH3 groups, right, OCH3, you have OCH3, OCH3 and OCH3, okay. So now if you see here, we have OCH3 and I will add R group here, and then we have one more OCH3 and R group here, okay. So this is your Friedel-Crafts. This name reaction is what? This is Friedel-Crafts alkylation, okay. Next, coming to concentrated HNO3 and H2SO4. So if we see this reaction, we will get OCH3, okay, this will add NO2 at the ortho position, and then we will get OCH3 and NO2 at the para position. So this is nitration, okay, this is reaction number 4, okay. I hope this is clear, okay. Very simple reactions, just you need to remember that OR group is a ortho para directing group, electron donating group. So it will direct the substituents to the ortho position and para position, okay. With this the reactions are over. Let us quickly revise once. First we have methods of preparation. Under that, the first one is dehydration of alcohols at 413 Kelvin, okay. Second one is Williamson ether synthesis. So here you must remember Rx plus R dash ONA takes place. Rx must be primary, okay, that is the very important thing. Second, coming to the chemical reactions, first one is the cleavage of CO bond. Here reaction with HX takes place, okay, and then if R1 and R2 both are primary or primary secondary or secondary, then reaction follows SN2 mechanism and the nucleophile or the X minus attacks on the less hindered site. If one of the R1 and R2 is either tertiary or is resonance stabilized, then there is the formation of carbocation. Reaction proceeds through SN1 mechanism and X minus attacks on the carbocation. Okay, so I hope this is clear. Then you have electrophilic substitution reactions. Here we have 4 reactions: nitration, which we already know, the reagent for that is concentrated HNO3 and concentrated H2SO4. Then you have halogenation, Br2 in acetic acid you can use. Next you have Friedel-Crafts alkylation and Friedel-Crafts acylation. Here you must remember that the para products are the major products, okay, in all these 4 cases. So just let me note down here, this will be your para product, that is your major product. Here this is para, so this is major. Okay, then also here this is major, okay, and here this one is your para product and this is the major product, okay, getting? Okay, so now we are done with the ethers chapter, ethers, reactions and everything. Now it's time to practice certain questions, okay. So before that I'll be telling you the answer of the homework question that I gave you in my last class. So you have to arrange in the order of their acidic strength. So first of all, nitrophenol, cresol and phenol. So nitrophenol, nitro is an electron withdrawing group, so it will be highly acidic, so 1 will be highest, so we can eliminate these 2 options. Next, cresol is your OCH3 group, so that is a electron donating group, so this one will definitely reduce the, so phenol will be after this. So one second, we have been given with 3 compounds, right? Okay, so just change this one, we have 3 compounds, okay, so these options we can just change. So I'll be telling you the answers here. So first one will be 1, okay, and then we have phenol 3 and then we have cresol 2, okay. So 2 3 1, so you can find 2 3 1 2 3 1, okay. So there is this 4th option is not there, so I like anything A or D you can mark it, clear? Okay, next question, okay, so now we'll be doing some PYQs. So when after completing this lecture, if you are able to solve these questions, then you can assure that your preparation is going on the right track, okay, because whatever questions we have taken, these all are from your PYQs of the last 5 to like 4 or 5 years questions, okay. So first of all, heating of phenyl methyl ether with HI produces an aromatic compound A, which on treatment with concentrated HNO3 gives B. A and B respectively are. So first of all, phenyl methyl ether, the structure of phenyl methyl ether is, if you treat it with HI, so what will I get? So first I'll get is phenol. As I told you, if O is there, undoubtedly you can, if phenyl group is there, then without any doubt you can write like this the product. Phenol you will get and CH3I you will get, right? Next, phenol HI produces an aromatic compound A. So this is your aromatic compound A, which on treatment with concentrated HNO3. So if you treat it with concentrated HNO3, if you remember, we used to get 2 4, all the ortho positions were getting blocked, right? Ortho and para positions. So we used to get NO2 like this. 3 positions NO2 group will come. So this compound is called as picric acid, right? So this is B. So A is phenol and B is picric acid, right? So the correct answer for this question will be option number D, okay. Next question, among the following the products formed by the reaction of anisole with HI, okay. Now anisole with HI, anisole is this one with HI or HX. So again I told you, whenever there is a phenol benzene ring is there, so definitely the product will be OH plus CH3I. So we have phenol plus iodomethane, right? So phenol plus iodomethane. So correct answer is option number C, okay. Next, which one of the following on heating gives an ether as a major product? Okay, so you can see all these options we are having RX and RONA, that is your Williamson ether synthesis. Now the condition for Williamson ether synthesis is your RX must be primary group, right? So if you see here, this is RX, this is primary, so this can give you. This one, if you see RX, this is also primary, this one can give you. Now if you see this one, this RX, this is a tertiary RX, right? So tertiary Rx will not give you, so this one cannot be there. And if you see this one, this is your vinylic is there, so it is like this, C6H5, then we have CH double bond CH and then Cl, right? So now what happens, due to resonance, okay, this bond breaking is not easy, so that is why this one will also not give you. So which one can form? Both P and Q. Okay, so correct answer is option number C here. Okay, next, the products formed during the following reactions are. So we have already discussed this example. So we have C with Me3, okay, and then O and then CH3, okay, with Hi. So I told you, if there is a tertiary one, then there is a formation of carbocation, right? So first of all, first step is O plus H takes place here, right? Then this one will break, I minus will attack here, so we will get C3Me, okay, then we have I, and then we have CH3OH, okay. So I is attacking to this group, right? So the correct answer for this question will be option number A, okay. Next, ethanol is converted to ethoxyethane. So they are telling ethanol, CH3CH2OH is converted to ethoxyethane, that is CH3CH2O CH2CH3, okay, by heating excess of ethanol with concentrated H2SO4 at 140 degrees Celsius. So if you convert this 140 to Kelvin, 273, that is 413 Kelvin, right? So when we heat dehydration of alcohols in the acidic medium at 413 Kelvin, we used to get alcohols, we used to get ethers, right? So yes, this is the correct answer. So this is the correct mechanism here, right? So if you heat at 443 Kelvin, what will happen? Dehydration will take place, will get ethene. Now if you take room temperature, reaction will not happen. At 273 Kelvin also reaction will not happen, okay. Fine, next question, okay, one second, okay. So this question is for yourself, okay, test yourself question. So this is also a PYQ. The question I'll read, okay. 0.44 gram of a monohydric alcohol when added to methyl magnesium iodide in ether liberates at STP 112 centimeter cube of methane. With PCC, the same alcohol forms a carbonyl compound that answers to the silver mirror test. The monohydric alcohol is. So here I'll just give you one hint for silver mirror test. Just remember that aldehydes give silver mirror test, not ketones, okay. So by using this, try this question, okay, little difficult question, I'll not say very easy one, but you can try this question and do not forget to answer in the comment section, okay. In the next class, I'll be discussing the solution for this question, okay. This is also a PYQ and a very important, easy and tricky question, okay. So students, we are done with this chapter, alcohols, phenols and ethers, a very big chapter you might think, and yes, we have completed this chapter very easily, smoothly. So I hope that you have understood all the reactions and you must have prepared the flow chart for this chapter as well, okay. So in the next class, we will be doing a revision of this chapter, okay. So I want everyone to attend that class so that once again we will revise this complete chapter, and then we'll go towards the next, in the next to next class, we'll go for aldehydes, ketones and carboxylic acid, okay. So students, I hope you are enjoying the classes, you are learning every day and you are like very regular with your preparation, okay. If you have any doubt in any of these concepts, do not forget to comment down. I will definitely address it, okay. Thank you for watching, and please join our WhatsApp channel so that you can get notes and everything, and do not forget to subscribe the channel so that you can get notifications about the classes that we are conducting. We have already started physics, maths, chemistry, bio series is going on, so you can join and this will definitely help with your preparation, okay. Thank you for watching and stay tuned for the next class where we are going to do the complete revision of alcohols, phenols and ethers.